Good day, grade 10 learners. I'm Christine Karen T. Sota, a teacher from Andres Bonifacio Integrated School, and I will be your guide in understanding Week 4 lesson, Geometric Series. At the end of this video lesson, you will be able to determine the sum of the terms of finite and infinite geometric sequence. Before we proceed further, let's have a short recall of a geometric sequence. A geometric sequence like 4, 12, 36, and 108 is a sequence where each term after the first is obtained by multiplying the preceding term by a non-zero constant called the common ratio. In this example, 3 is the common ratio. On the other hand, a geometric series is the sum of the terms of a geometric sequence, written as a string of terms connected by addition or subtraction if necessary. In our example, we have 4 plus 12 plus 36 plus 108, and the geometric series is denoted by S sub n. Here are the formulas in finding the sum of terms of a finite geometric sequence. A finite geometric sequence is a sequence that has a definite number of terms. To better understand when and how to apply these formulas, let's have the following examples. Find the sum of the first 5 terms of the sequence in which a sub 1 is equal to 7 and r is equal to 4. Since the common ratio is not equal to 1, so we have two options. But since in our given problem, a sub 1, common ratio, and the number of terms are given, so we will be using the first formula, and that is S sub n is equal to a sub 1 times 1 minus r raised to n all over 1 minus r. Next thing to do is we substitute the values of a sub 1, r, and n. We have here s sub n. Since we are looking for the sum of the first 5 terms, equals the first term is 7 times the quantity 1 minus the common ratio is 4. So we have 4 raised to n. So we have 4 raised to 5 all over 1 minus 4. So next is we simplify. So we have 7 times, we have 1 minus 4 raised to the 5th power is 1024. Then divided by 1 minus 4 is equal to negative 3. We simplify further. So we have S sub 5 is equal to 7 times 1 minus 1024 is negative 1023 divided by negative 3. So to find the final answer, we have 7 times negative 1023 is negative 7161 divided by negative 3. So the sum of the first 5 terms of the given sequence is 2387. Let's have the next example. Find the sum of the finite geometric sequence whose a sub 1 is equal to 162, a sub n is equal to 2, and r is equal to negative 1/3. Again, since the common ratio is not equal to 1, so we have two options. But since in our given problem, the first term, the common ratio, and the last term are given, so we will be using the second formula. And that is S sub n is equal to a sub 1 minus a sub n times r all over 1 minus r. Next, we simply substitute the values of first term. We have 162 minus the last term, a sub n, that is 2, times the common ratio, negative 1/3, all over or divided by 1 minus common ratio is negative 1/3. Now we simplify. We have here 162. Negative 2 times negative 1/3 becomes positive 2/3. So we have plus 2/3. All over, we have 1 So negative of negative, that becomes positive. So we have 1 plus 1/3. We simplify further. We have here 162 plus 2/3 is 162 and 2/3. So we have to express it in proper fraction. So what we do is we multiply the denominator. We have 3 times 162 is 486 plus the numerator 2. So we have 488 over, we simply copy the denominator 3. So 488 over 3 divided by 1 plus 1/3 is 1 and 1/3. Again, we have to express it in an improper fraction. So we have 3 times 1 is 3 plus 1 is 4. Then copy the denominator 3. So we have 488 thirds divided by 4 thirds. So applying the rule in dividing fractions, so we cancel out this 3. We have there 488 over 4. And the sum of n terms, S sub n is equal to 122. Find the sum of the first 8 terms of negative 5 plus 5 minus 5 plus 5 minus 5 and so on. Our common ratio is obtained by dividing the second term by the first term. So we have 5 divided by negative 5 is equal to negative 1. And if r is equal to negative 1, we use this concept. If n is even, the sum of the n terms is actually 0. In this problem, our n is 8. And since 8 is an even number, so we say that the sum of the first 8 terms, or S sub 8, is equal to 0. So if we are going to analyze, adding the first 8 terms of the given sequence, we have negative 5 plus 5, minus 5 plus 5, minus 5 plus 5, minus 5 plus 5, and pairing these two numbers at a time, negative 5 plus 5 is equal to 0. Negative 5 plus 5 is 0. Negative 5 plus 5 is 0. Negative 5 plus 5 is 0. So adding these four zeros is still equal to 0. This time, find the sum of the first 11 terms of negative 5 plus 5 minus 5 plus 5 minus 5 and so on. Since the common ratio is negative 1, we will apply this concept. This time, if n is odd, we have the sum of the n terms is equal to a sub 1. In our given, n is 11, and 11 is an odd number. So we say that S sub 11, or the sum of the first 11 terms, is equal to first term, which is negative 5. If we are going to expand this one, so we have negative 5 plus 5 minus 5 plus 5 and so on to the first 11 terms. And we pair up negative 5 plus 5, that is 0. Negative 5 plus 5, 0, 0, 0, 0. One term will remain, and that term will always be equal to the first term. Find the sum of the first 15 terms of negative 9 minus 9 minus 9 minus 9, and so on. Since all of the terms are the same, we say that the common ratio is equal to 1. And if the common ratio is equal to 1, we use this formula. S sub n is equal to n times a sub 1. We substitute the values of n and a sub 1. N is the number of terms, so we have first 15 terms, so n is 15. So equals n, 15, times the first term, and that is negative 9. So the sum of the first 15 terms is 15 times negative 9, negative 135. Find the sum of the first 18 terms of the series 5, 6 plus 5, 6 plus 5, 6, and so on. Again, the common ratio is equal to 1 since all of the terms are the same or equal. We apply the formula n times a sub 1. Substitute the values of n. We have 18 and a sub 1 first term. So multiplying 18 and 5, 6. So the sum of the first 18 terms, or S sub 18, is equal to 15. 18 times 5 divided by 6. What if the given is an infinite geometric series? This time we will be using a different formula, and that is s to infinity or sum to infinity is equal to a sub 1 over 1 minus r. We will be using this formula if the given infinite geometric series satisfies the condition that the absolute value of its common ratio is less than 1. Let's have the following examples. Evaluate the infinite geometric series 8 plus 12 plus 18 plus 27 and so on. Let us first determine the common ratio by dividing two consecutive terms. So we may have second term divided by the first term, 12 divided by 8, or third term divided by the second term, or fourth term divided by the third term. All of these will come up with a common ratio 3 halves. The absolute value of 3 halves is still 3 halves, and it is not less than 1. So it is impossible for us to find the sum of this infinite geometric series. Thus, we say that the sum does not exist. But what if we have this infinite geometric series, 27 plus 18 plus 12 plus 8, and so on? Identify the common ratio by dividing two consecutive terms. Second term divided by the first term, we have 18 divided by 27, or third term divided by the second term, or fourth term divided by the third term. All will come up with the common ratio 2/3. And the absolute value of 2/3 is still 2/3, and it is less than 1. So we may use the formula s to infinity is equal to a sub 1 over 1 minus r. Let us substitute the values of the first term, that is 27, over 1 minus the value of the common ratio is 2/3. So simplifying this one, we have the sum to infinity is equal to 27 divided by 1 minus 2/3. That becomes 1/3. So what you just need to do is we multiply here the denominator 3 times 1. That is 3 minus 2. So the numerator is 1. Then over 3, simply copy the denominator. Then 27 divided by 1/3 is equal to 81. So the sum to infinity of the given infinite geometric series is 81. Lastly, let's have this infinite geometric series 1/2 minus 1/5 plus 2 over 25 minus so on. Let us find the common ratio. So we divide two consecutive terms. We will come up with negative 2/5. The absolute value of negative 2/5 is positive 2/5. 2/5, a proper fraction, is less than 1. So we may use the formula in finding the sum to infinity. That is a sub 1 divided by 1 minus r. Substitute the values of a sub 1, which is 1/2 first term, and the value of the common ratio, that is negative 2/5. Simplifying further, we have the sum to infinity is equal to 1/2 divided by, so 1 minus negative 2/5, this becomes plus. So negative to negative. So that becomes 1 plus 2/5, and that is 1 and 2/5. So we have to express that in an improper fraction. So we copy 5, the denominator. Then 5 times 1 is 5 plus 2, that is 7. So we have 1/2 divided by 7/5. Applying the rule in dividing fractions, so we have 1/2 times the reciprocal of 7/5. That becomes 5 over 7. So we have the sum to infinity is multiplying 1 times 5, that is 5, and 2 times 7 equals 14. So we have 5 over 14. Happy learning!